homework from last night, I'm going to write down the answers that you should have had. All right, so you're going to check your work. All right, so first one. All right, if you can raise your hand and tell me, I'll give you a prize if you can raise your hand. Yeah? Oh, no, I wasn't going to say, no, that wasn't the answer to the question I was looking for. Yeah, for the question I was going to ask, yeah. Your question? You didn't even ask a question. You made a statement. In your mind, it's right. The question is, if you can raise your hand.
We're just getting ready.
I don't know what I'm going to ask. It's like Jeopardy. If you raise your hand, you lose your turn. You know, if you don't, you got to wait for the question, folks. All right, that's the point. So I'm training you for when you guys go on Jeopardy someday. Which, by the way, that's my goal. The next teacher term that comes around, I'm going for it. Going for it. Wow.
You would literally win like 100.
Who? Me? Me? I know I would. I would.
Sorry, you're not smart.
Who can raise their hand and tell me the correct name of this compound right here? Joe.
Potassium.
Yes.
Manganese.
Potassium permanganate is the name here, guys. The correct answer you should have.
Where did we learn that?
Where did you learn it? It's on your list of polyatomic ions, folks. 158.04. All right, the next one. Raise your hand and tell me the name of it for a prize. Chase. Potassium chloride. The correct molar mass that you should have had here is 74.55 grams per mole. Next one, same thing. Raising your hand. Joe.
Disodium sulfate.
No. Riley. Sodium sulfate. 142.05 grams per mole. Next one. Sam. Calcium nitrate. 164.1 grams per mole. That was one from our notes, actually. The next one, Caroline. Aluminum sulfate. The correct molar mass here you should have is 342.17 grams per mole. The next one, Joe again.
Ammonium phosphate.
Ammonium phosphate. Give him a round of applause, folks. He finally got it. The correct molar mass you should have is 149.10 grams per mole. We're going to skip number 7.
Oh, I knew it.
And the last one here, raise your hand, Josh. Magnesium phosphate. The molar mass you should have is 262.87 grams per mole. Now, I will give a bigger prize to whoever can tell me the correct name of number 7 here. You get one guess. Compound, right? There's something different here. What's different about this one? That dot, right? Yeah, that dot. So, I'm going to write up the correct answer here. The correct answer, guys, for this molar mass is 249.70 grams per mole. Did you get it right? Did you show your work? Let me see it. You got it right? Let me. What we call a hydrate. All right. Now, are there any questions about the other 7 that you would like me to go over? How did we do on those 7? Pretty easy? All right. For those of us who did it. Now, guys, this hydrate, obviously we can see there's a difference here. And that's this dot right here. Now, when you think of that dot, typically from what you know with like math class, what does that dot tell you to do? Multiply, right? But in here, it's not actually multiplied. So what I'm going to do is I'm going to kind of write out this generic form of this structure of what's actually going on. So we've got copper 2 sulfate. Okay. Actually, I'm going to erase that. I'm going to redraw it. CuSO4. So that's like one structure right there, guys. And then what that dot means is that it's like we have 5 water molecules attached to that copper 2 sulfate. That's what a hydrate means. You kind of get that with the name that, oh, water is involved, which we could see that. This is kind of, not exactly, but you get the idea, guys, just a general representation. This is what that structure looks like. So it's got that core structure of the copper 2 sulfate, and there's these 5 water molecules around it. That's where you get that hydrate. So that dot is just showing that, hey, water molecules are attached to it. We're not actually going to multiply by water's mass, but we're going to actually take that into account when we do the molar mass. And that's what I'm going to show us here today as a quick review. So I've got my formula, CuSO4.5H2O. So kind of walk me through the process here of how we calculate molar mass in general. What's the first thing we taught you to do, Josh? Right, and I think this was you were just answering this question a while ago, right? You're just way ahead of the game. Yeah, absolutely. So we've got copper, we've got sulfur, we've got oxygen, and then guys, with a hydrate, what you can do is you can keep it all together, or you can separate it out into its individual components. With hydrates, I like to keep it as water all together. All right, so then I'm going to separate them out. Now figure out how many of each I have. How many coppers do I have? I've got 1. How many sulfurs? 1 sulfur. How many oxygens? 4. How many water molecules do I have? 5. Okay. So now I'm going to multiply those by the masses of each one. Copper's mass, molar mass, is what? Where'd you get that information? Get your periodic tables out, guys, if you don't have them. So copper is 63.55. Sulfur is, oxygen is, all right, so that math is pretty easy. 63.55 is what copper is going to bring to the table. Sulfur is going to bring 32.07. 4 times 16 is 64. Now, water, folks, we've got to add up the mass of hydrogen and oxygen. It's kind of like doing a molar mass in one step here is what we're doing. Oxygen we know is 16. Hydrogen, what's the mass of hydrogen, guys? Basically, it's 1.008. So when you multiply that by 2, you get 2.016. We add that to 16, guys. The mass here is 18.016. When we multiply that by 5, do it with your calculators, guys. What do you get? Start punching it in, folks. You've all got calculators in front of you. You're going to need them today. 90.08. Now, that's the individual pieces, guys, the individual components of each element or each substance that brings to the table. How do we get the total molar mass? Add them all up. It's the sum of all the masses. So, when we add it up, we get, again, it's 249. And what's our unit? Grams per mole. Grams per mole. So that's what we went through yesterday, guys. We kind of rushed there at the end a little bit. We're going to do more practice. We're doing it a lot. Is this that difficult? No. We've done a lot harder stuff, guys. Don't make it harder than it needs to be. Okay? So again, remember that this 5 coefficient distributes in just like a subscript would have. Like we had nitrate yesterday, like in calcium nitrate. We had this compound. The 2 distributed in. Coefficients do the same thing. Folks, we will be dealing with coefficients in our next unit on reactions a whole lot more. This is just kind of a little introduction. We won't be doing a whole lot, but just introducing it to you. Guys, in our notes, we're going to kind of go back. We did not do the reverse process, and we might have done one yesterday, so flip back to the front page of your packet. All right, did we do the first one?
Yes.
All right, so we did that. I'm going to just write it up there just for the sake of as a review. Yep, we're going to do that here. Wait, did we do the first 2 yesterday?
We just did the first.
Some of you guys kind of went ahead. That's great. So here we go, guys. As a quick review, what goes over underneath the first fraction? 1. It's a placeholder. All right. Particles we're going to write down here because that's what we're trying to get rid of. All right. Then we're trying to get to moles in the top. How are these 2 terms related? Moles and particles. 1 mole is what? 6.02, which is whose number? Not avocado. Avogadro's number, guys, right? 1 mole. In your reference packet, folks, if I didn't point it out to you guys yesterday, the very front page, you have his number there, so you don't ever have to really memorize it. I mean, you will. If the song didn't do it for you, using it a lot is going to. But you have it there in case you have you forget it on the test or quiz. So 1 mole, 6.02 times 10 to the 23rd. That's going to cancel out. So we have 1 mole for this one. Right here, same setup. All right, atoms now. What's the difference between atoms and particles? Is it a different number that we use? No, it just tells you what type of substance you're looking at, guys. Don't let the unit confuse you. It's still the same number. It's a particle. Atoms cancel out. This is going to be 2 moles. All right, so you guys try the last one there if you have not done so already. All right, so check your work, folks. Remember, ions is the same thing as atoms or particles. Don't let it confuse you. All right, 1 mole over 6.02 times 10 to the 23rd ions. Ions will cancel out. When you do this, you should end up with a very tiny number, guys, because your exponent right here is times 10 to the 20. You're dividing by a bigger number, so it should be a small number. I believe you get 2.49 times 10 to the minus 4 moles is what you should have. 0.000249. We never did the last one on the recap, guys. We can use grams as conversion factors as well. Again, word problems. I'll get your question in just a minute. Write down what you're given, guys. We're starting with 2.0 moles. All right? We're trying to get to grams of helium. So it's very important, guys. You've got to get in the habit of not just writing grams down, but what substance you have as well. All right? What substance? Because is every element the same mass? No. All right, so you've got to identify what substance you're looking at. So we're looking at helium here. Moles will go on the bottom. Grams are going to go on the top. All right. Notice, guys, every time we have a conversion factor where we're converting between moles and grams or moles and particles, what is the number that always is there with mole? 1, guys. Mole always gets 1 in your conversion factors. The other number is going to go with the other unit. So where do we figure out how many grams are in 1 mole of helium? Periodic table. So, what's the molar mass of helium?
1.008.
Helium. We're going to round it to 0.003 there, Mikey, but you're absolutely right. All right. So, when you do this math out, guys, you get a final answer of 8.006 grams of helium in 2 moles. All right. So, when you have 2 moles of helium, that number of particles, guys, your mass is going to equal 8.006 grams. All right? Let's try the next one there together. So, how many moles are in 3.01 times 10 to the 23rd atoms of silver? Okay, so what's our first step to do? Given. Write down your given information to set up your T-chart. I have 3.01 times 10 to the 23rd atoms of silver. I'm trying to get to moles. So, if I were to write my conversion factor here at the top, my equal statement, what's the number, guys, that's going to be with mole? Always? 1. Now, atoms. Are atoms the same thing as grams? No. So are we going to look at our periodic table for the number of atoms? No. What number goes with atoms? Yeah, that big one, guys. Think about it. Think to yourselves, does my answer make sense? When I'm trying to figure out atoms and moles and how they're related, can you see atoms? No, if I had 2 atoms, could I see that? No, because they're so tiny, guys. So it takes a lot of atoms to make up 1 mole. Avogadro's number is what we're using here. So then let your units drive your math. Set those up first. Atoms on the bottom. Moles on the top. Cross them out. 1 mole from our conversion factor. 1 mole goes with 1. And then atoms has 6.02 times 10 to the 23rd. Go ahead and do the math. The answer here is 0.5 moles. Moles. So guys, listen. Every time you're converting to moles, whether you're going from grams to moles or particles to moles, moles is always going to be a smaller number. And if you think about it, that should make sense because that's our counting unit. That's the purpose of a counting unit, is to make your numbers more manageable. All right, so they're not as big. as the ones you're trying to relate them to. Just like dozen, right? 3 dozen is 36. That's why we say 3 dozen instead of saying 36, the giant number there. You guys go ahead and try example number 3 in your notes. I don't want you guys to try this one. Mikey. You know how big a mole is.
No, but like, is it that big?
It depends on what you're looking at. It changes depending on the substance. Because those are all moles right there of those 5 substances, but it depends on the element or the substance you're looking at. Shh.
He discovered moles, right? His name's Avocado. Avocado guacamole.
Wow. Wow, we're getting deep here. Woo.
He goes, oh wait, dude, I got it.
Wow. Maybe he was eating. What if he was eating? Hey, Ethan. What if he was eating guacamole at the time?
I don't think they had guacamole.
Really? I don't know. Folks, if we take a look at this problem, guys, if we take a look at this problem right here, what do you already know that's different about this problem than one we've already done?
Mass.
We've had mass, but it's mass of atoms, like you said, right? So, guys, is this going to be a one-step problem? Have we ever gone between mass and atoms directly? No. So let's think about this, guys. Let's kind of ballpark or kind of game plan what we're going to do here. What am I starting with?
1.20.
Right. So my unit that I have is atoms first, and it is exactly what Ethan said. But can I go right from atoms to grams? I have to go to what first? You always have to go back to moles first. So we go to moles. Then when I have moles, can I go to grams? Absolutely, guys. So we can see how many steps is this going to be? This is going to be a 2-step problem. We're going to have 3 fractions. Right? Here's step 1, going from atoms to moles. And here's step 2, going from moles to grams. Same process, folks. Write down what you're given to start with. 1.20 times 10 to the 8th atoms. This is where writing your units down, guys, and looking at those becomes so important. Your units will drive your math. Set up our T-chart. All right. First one, it's always over 1. Now, where does atoms have to go? On the bottom, right, to cancel out. So atoms goes here. What's going to go? What is my unit that's going to go on the top? Moles, right? That's what we game plan here at the top, guys. Atoms goes back to moles first. So those 2 are me right here. Now, how are those 2 related? Yeah, so mole gets what number? Always 1. Atoms will cancel out. In 1 mole, how many atoms do I have? All right. Now, I'm left with moles. Is that the unit I'm trying to get to in the end? No, so we need another conversion back, guys. This is step 2 that we game planned here up at the top. Now we can go moles to grams. So set up your units first. Moles is on the bottom. Grams is on the top. Moles will cancel out. Grams is the unit we're trying to get to. So that's good. Mole always gets what in a factor? 1. Now, 1 mole has how many grams? Now, it's not just grams. It's grams of copper. So we want to put that substance in there. Where do we figure out how many grams are in copper? Periodic table. So how many are there?
63.55.
There we go. Folks, there it is. We just converted from atoms to mass. Notice, guys, anytime that it says mass, that means grams. Okay, so make a note to yourself. Mass equals grams. That's the unit. Now all we have to do is do the math, guys. And this is where, remember way back in Unit 1, I started telling you how to plug it in the calculator. Top times top times top. Divide by bottom, divide by bottom, divide by bottom. It'll get you the right answer every single time. Do you have to put the 1s in there? No. You don't have to worry about those, guys. But you're going to take 1.2 times 10 to the 8th times 63.55 divided by Avogadro's number. Go ahead and solve for it.
266,774,09 times 10 to the 32 grams.
I got negative.
Negative 14.
You should end up with 1.27 times 10 to the minus 14 grams. If you didn't get that, guys, if you got a giant number, you probably divide or multiply it instead of divided. All right? Again, guys, now's the time to make those mistakes with the calculator. We're practicing with it. All right? It's okay to make mistakes now. You don't want to make them on a quiz or a test. So if you're having consistent calculator issues, not getting the right answer, call me over. I'll show you guys. I'll help you make you see what you're doing wrong. Questions with this problem, guys? Now, yes, it's a two-step problem, but is it that bad? We've kind of done this, guys, now. Let me ask you this. Do conversions seem a little bit easier now than when we did them back in Unit 1?
Yes.
Because we're not dealing with the metric system, guys. Your units are the key. You write the units in first. Your numbers then will follow along. I want you guys to do these two problems. All right? Go ahead and do these two problems, and we'll check them here in a couple minutes. To work these out for you. All right, so check your work. Write down what you're given, guys. We are starting with 11.5 grams of boron. It's very important, guys, that you actually write down what element you have, because that's going to help guide you to figure out what answer you need. We're trying to get to moles of boron. Put our 1 there as a placeholder. All right, so grams of boron goes in the bottom, which means we're going to try to get to moles to boron. Grams will cancel out. So 1 mole of boron has how many grams? Where do you figure that out? Where do we find that information? Periodic table, 10.81. When you do the math, guys, you should end up with 1.06 moles of boron. Questions on that one? All right, the next one, guys. Now, this is like that problem that we just did together. Example number 3. We're going from atoms to grams. Take it one step at a time, guys. Write down what you're given. All right? If we're going from atoms to grams, think. We got to go atoms to what first? Moles. Then we can go moles to grams. All right? So I have 8.0 times 10 to the 19th atoms of silver over 1. Atoms of silver goes on the bottom. Moles of silver will go on the top. 1 mole of silver. How many atoms are in a mole?
6.02 times 10 to the 23rd.
Okay. Now, do I want to stay at moles? No, I'm trying to get to grams. So, moles of silver on the bottom, grams of silver on the top. 1 mole has how many grams of silver? You look at our periodic table.
8.7.
There we go. So now you do your math, guys. When you do the math out, what do you guys get for a final answer?
0.014. There's a lot of
1.43 times 10 to the negative 6.
Right, guys. So you could say, you could put it in scientific notation, or you could put it in decimal notation. Either way, it's the same answer. It's 0.014?
Yeah.
Sorry. Wrote it wrong. 0.014 grams of silver. Questions? How are we feeling, guys? Thumbs up. If we take a look, guys, we have conversion factors now using molar mass. So if you're given a substance, a compound, you've got to calculate the molar mass first before you can actually convert it from grams to moles. So sodium chloride, we did that yesterday. We added them all up. 58.44 grams. Same thing, MgCl2, calcium nitrate. We can use those as conversion factors. We will have to use compound formula masses as conversion factors. All right, you're going to have to do that with your homework tonight. So let's do this right here. Let's do this example. I believe this is in your notes. On page 4 of your notes, example problem. It says, how many moles are in 127 grams of barium chloride? So this is where naming comes into play. If you could not name in our last unit, guys, you're going to lose points here because I give you the name. You have to come up with the formula. So that's the first step we have to do here is we got to come up with what formula we have to then be able to get our molar mass from it. Barium chloride. Do you see prefixes there? No. So what type of compound do you have? Ionic. Ionic compound, you use what method to figure out the formula? Crisscross, guys. Barium, what's the charge on barium? Chloride. So when we crisscross those up, our formula then is BaCl2. So before we can start converting, guys, from moles to grams, we need to know the molar mass of barium chloride. So, go ahead and start figuring that out. Write down your elements. BaCl. How many bariums do I have?
1.
How many chlorines?
2.
What's the molar mass of barium?
137.38.
That makes our math easy, 137.38. Let me go ahead and erase this stuff right here. Okay.
35.45.
35.45 times by 2, 70.9. When you add those up, guys, what do you get for your molar mass of barium chloride?
208.28.
That's it?
Erase it.
Grams per mole, guys. So that's the first step to this problem is you've got to know your molar mass. Now we can go ahead and solve for it. Write down what you're given. 127 grams of BaCl2. Set it up. What are we trying to get to? We're trying to go from grams to moles. How many steps is that going to be? One step problem. All right, so grams of BaCl2 on the bottom, moles of BaCl2 on the top. All right. 1 mole has how many grams? We just calculated it to be 208.28. Grams will cancel out. Go ahead and do the math, folks. What do we get for a final answer?
0.97560.
One more time.
0.61.
0.61 moles. So, page 5 is your homework. All right. We'll do the other homework I had. We will do that tomorrow.